This section, P8, is about application type problems. You may have heard of them called word problems. And we're just using equations to solve problems, which makes it sound simple. Why do you think it's important to learn about this concept? You should have already filled this in, but if not, pause the video now and go ahead and answer that question. So a model is a representation of a real-world situation. We obtain models by translating from English into math language, basically, algebraic equations. So in general, what we do is read the problem, let X represent one of the quantities, but it's always the quantity that's not described. Always make X the quantity that's not described. Sometimes you have to write expressions for other unknown quantities. That happens very frequently. Write a verbal write an equation for the verbal condition. Solve the equation. Check in the original problem to see if it makes sense. All right, so when you read these problems, frequently there's a lot of extra words in there that we don't really need. For example, if you look at this one, it says the median yearly before tax income. Do we need to know its median and yearly and before tax? Not so much. Income of a full-time worker. Do we need to know it's a full-time worker? No. What's important is that they have a bachelor's degree. So the income of somebody with a bachelor's degree, so all that word boils down to the income of somebody with a bachelor's degree, exceeds. Exceeds means more than a full-time worker with an associate's degree. Okay, so again, do we need to know that it's a full-time worker? No, we just need to know that we're comparing a bachelor's degree with an associate's degree by 15,000. The median yearly before tax income of a full-time worker with a master's degree, again, we don't care about any of this. This is what's important. Somebody with a master's degree exceeds that of a full-time worker with an associate's degree by 30,000. Okay, so we've got income for somebody with a bachelor's degree. We've got income for somebody with an associate's degree. We've got income with somebody with a master's degree. Okay, one of those was not described. In other words, I said income of a bachelor's degree does something. I said income of a master's degree does something. What I didn't say was income with an associate's degree does something. The associate's degree is going to get the X. The one that's not described gets the X. We're going to write the bachelor's degree in terms of X. What does that mean? Well, it exceeds, is more than the associate's degree by 15,000. So if I take my associate's degree X and add 15,000, everything's going to be in thousands, then that would be how much the bachelor's degree makes. And in a similar way, a master's degree exceeds, is more than, an associate's by 30. So we take our associates and we add 30. Okay, combine. When it says combine, combine means add. So if I take my bachelor's degree, I'm going to write here down here, my bachelor's degree plus my associate's degree plus my master's degree, combine, they would get $195,000. Okay, so find the median yearly income of each level. All right, so we're going to take our bachelor's degree. We said our bachelor's degree was x plus 15, so I'm going to replace my bachelor's degree with x plus 15. My associate's degree we said was x, and my master's degree was x plus 30. Be super careful when you do this. If you have 3 different quantities, you have to have 3 different x's. I cannot tell you how often students write an equation and they only end up with 2 x's, even though they have 3 quantities that they're trying to find. You would solve this equation. I'm running out of room. I do have room on the next slide, but I want to kind of keep everything all together. 3x plus 45 is equal to 195. And usually solving the equation is pretty straightforward. It's the setting up of the equation that you need to work on. So you end up with x is equal to 50. Now remember that was in thousands. And that's just x. We need each level. So an associate's degree, they made 50,000. But a bachelor's degree made 15,000 more. So if you add 15,000 to that, that would be 65,000. And the master's degree made 30,000 more than the associate's. So that would give you 80,000. I had space. I just didn't want to go to the next slide. You drive up to a toll plaza, find booths with attendants where you can pay the toll by cash or credit card. With this option, does it matter? No. With this option, the toll is $5 each time you cross the bridge. Okay. Anytime it says each, that means you're going to multiply times something, usually x. So option, we're going to call that option A. $5 each time you cross the bridge, where x is bridge crosses. Okay. The attendant offers you a different option. We'll call that option B. You have to pay $25, so you got to pay $25. And then you get a 25% discount off the $5. So you still have to pay money each time you cross. Still got to multiply times x. But you get 25% off. Okay. So how do you figure out a discount? You take the original price, you multiply it times the discount, and then that's the amount of discount. So then you take the original price and minus that amount of discount. Well, long story short, 1 minus the discounted rate is how that works. I factored out a 5, and that's what you end up with. So this is the discounted rate, this is the discounted rate. So 1 minus the discount rate times the original price. Okay, well, I ran out of room, so let me do option B down here. Option B. Okay, so I take $5, 1 minus the discount rate, which is 25%, times each time I cross the bridge, plus the $25 that you have to pay for the barcode. Okay. Well, if you take 1 and subtract 0.25, you get 0.75. And if you multiply 0.75 times 5, offhand, I don't know what that is. Let me, times 5, I get 3.75. So $3.75 each time I cross, plus the initial $25. That's option B. Find the number of times you would need to cross the bridge for the two costs to be the same. When it says the costs have to be the same, you set them equal to each other. What does it mean? Set them equal to each other. I say that phrase a lot. You need to know what it means. It means write down option A, put an equal sign, and then write down option B. And solve for x. Gives me $1.25. And we divide so 25 divided by 1.25, x is equal to 20. So you'd have to cross the bridge 20 times in order for the two different options to be the same. If you cross very infrequently, then you're probably better off just paying the $5 each time. But if you're crossing several times a day, then option B would definitely be the way to go. Okay, and I lost that problem. But you have it in your notes, so let me find it. All right, as a reminder, if I accidentally go too far on the slides, I can't go back with the way that with the software that I'm using to record, but you should have this in your notes. So I'm going to read the problem. After a 30% price reduction, you purchase a new laptop for $840. What was the laptop's original price before the reduction? So we kind of talked a little bit about this already. If X is the original price, well, let me just write down words. Let's try this again. So we have the original price. We subtract off the discount, the amount of discount, and that equals the reduced rate, the new price. Okay, but the amount of discount is found by multiplying the original price times the rate. Okay, so the original price minus the original price times the rate equals the new price. And you can either leave it like that or you can factor out the original price and write it as 1 minus the rate equals the new price. Okay, so we're going to use the information that we have. They told us there was a 30% discount. I'm going to call X the original price. There was a 30% discount, and our new price was $840. So if we take 1 and subtract 0.3, we end up with 0.7. And divide by 0.7, and we get 1,200. The laptop was originally $1,200 before the discount. Okay, let's see. You inherit $50,000. This is a very common word problem. You inherited $50,000 with the stipulation that for the first year the money had to be invested in 2 accounts, one paying 0.9% and the other paying 1.1%. How much did you invest in each account if the total interest earned for the year was $515? Very, very common word problem that you're going to see in algebra. Easiest way to do this is to set up a table. You do need to know that for simple interest, the formula is principal times rate times time, but in this example, they gave us 1 year for the first year. So time is equal to 1. So principal times rate times 1. Okay, So we're going to have the principal, and we're going to set up a table here, the interest rate, and then the amount of interest. Okay, so these multiplied together equal the interest. So we're going to have the first account, let's call it account A, and the second account, let's call it account B. And they have one at 0.9%, which means you have to move the decimal 2 places. So 0.009 is going to be the rate. And then the rate for the other one as a decimal. Now, they told us that altogether you inherited $50,000. So just pick one to call X. Doesn't really matter. To find the other one, be really careful. What happens is you have X plus your account B, and that is equal to the 50,000 total. So to figure out how much you invested in account B, you subtract your X. If you know the total, then you're going to take 50,000 minus the first account. Okay, it always works that way. You take the total minus X. So many students do X minus 50,000, get the wrong answer. Okay, so we need to multiply. That's a multiplication. We need to multiply X times 0.009. And we need to multiply these two together times 50,000 minus X. And see, this is the amount of interest that they earn for account A, right here. I forgot my X. And this is the amount of interest that they earn for account B. If you add them together, you get a combined total. Anytime you see that word total, think addition. You get a combined total of $515. So what you're going to do is set up your equation where you add those two together and set it equal to 515. Now this one I do have to go to the next slide so I have some room to work. All right, so here's my point, 0.009x, and I'm going to add 50,000 minus x is equal to 515. And then I'm going to solve. I need to distribute. And let me check to see what that is. 550 minus, too many zeros, equals 515. Combine like terms. So I can combine these, 0.002x. I'm going to go ahead and subtract my 550. I don't know what that is. Negative 35. And divide. And when you divide, you end up with 17,500. That was account A at 0.9%, because that was my X. Okay, now you have to go back to the original problem to make sure you answered the question that's asked. Again, I can't go back on my slides, but it says, how much did you invest at each rate? So we need to know both of them. So to find the other one, we would take our 50,000 and subtract our 17,500, and that gives us what? 32,500. So 32,500 at 1.1% interest. Very, very, very common problem, word problem, is with the different interest rates in two accounts. Also a very common word problem, the length of a rectangular basketball court. So draw a rectangle. Is 44 feet. It does not say it's 44 feet. It's 44 feet more than the width. So they did not describe the width. I'm going to call it W. But they did describe the length. It's 44 more than the width. Okay? They didn't say the width was something or other. They said the length was something or other. So the one that was not described as the width, that one is the one that gets the variable. If the perimeter of the basketball court is 288, so we need to know the formula for perimeter, or just add up the sides, keeping in mind that it goes all the way around. I cannot tell you how many students just add 2 of the sides and forget about the other 2. Make sure, if you're just adding up the sides, make sure you add up all 4 sides, not just 2 of them. So we've got 2 of the W's plus 2 of the 44 plus W's. So 2 of the widths and 2 of the lengths. That's the formula, by the way. 2 of the lengths and 2 of the widths is the perimeter 288. Okay, so we're going to solve. And like I said, solving the equations is not the difficult part. Usually, they try to make the equation itself, they give you easy numbers, but coming up with the equation, that's the one. And it just comes with practice. Just do it, practice, practice, practice. So you get a width equal to 50, what's the unit? Feet. When it says dimensions, the answer is it wants both the length and the width. So make sure you answer both of those. The length is the width, which is 50, plus 44. So you end up with a 94-foot length. Dimensions means you need to give both the length and the width. Reminder about the Pythagorean theorem, a squared plus b squared equals c squared. You would have seen this in lots and lots and lots of different classes. Dimensions of a TV. You can tell it's old because it's not a flat screen. All right. So what is the size of the screen? When they say the size of the screen, what they're asking is a diagonal. Anytime they tell you it's a 32-inch TV, what they're talking about is the diagonal is 32 inches, right? Not the length and the width. So what you're going to do is take one of the legs and square it. The other leg squared is equal to the hypotenuse squared. And I do not know these off the top of my head, so I still don't know that off the top of my head. Okay, so let's go ahead and multiply 19.2, which is 368.64, and 25.6. We're going to square that. 655.36. We're going to add those together. 0.64. 24 is equal to c squared. It's c squared, not c. So in order to find it, we have to square root both sides. Unlike with the square root property where we have to remember the plus or minus, this is a length, which is always going to be positive. So if we take the square root of 1024, we get 32. inches. All right, and I think that might be the last problem. Let's check. Yep, reflection. Make sure you fill in answer these questions at the bottom of your guided notes. And there you go.